while in many cases they are augmented with additional approaches to enhance performance for specific problems. These techniques can be widely adapted to not only TSP and its variations, but to other hard optimization problems as well. Additional applications include the TSP, quadratic assignment, and job shop scheduling. Following are some meta-heuristic approaches used to solve the traveling salesman problem: simulated annealing, taboo search, genetic algorithms, and ant-colony optimization. The rest of the presentation deals with the implementation concepts and results of ant-colony optimization. Ant-colony optimization. Here we are going to discuss ant-colony meta-heuristic overview, ant-colonies in optimization, then real versus artificial ants, and analysis of ant-colony optimization. Overview. Ant-colony optimization studies artificial systems that take inspiration from the behavior of real ant colonies and which are used to solve discrete optimization problems. Ant colonies in optimization. Ant colonies are a nature-inspired, swarm-based, iterative computational paradigm for discovering optimal solutions to combinatorial optimization problems. The paradigm models the foraging behavior of ants. It is based on the idea of a number of agents that share their experience in solving the problem and are influenced by the experiences of others. Real versus artificial ants. When we map a real ant to an artificial ant, we have to consider some more facts. Discrete time steps, memory allocation, quality of solution, time of pheromone deposition, and distance estimation. Stigmergy. Stigmergy, a term coined by French biologist Pierre-Paul Gras, is interaction through the environment. Two individuals interact indirectly when one of them modifies the environment and the other responds to the new environment at a later time. This is stigmergy. Goal of ant colony optimization heuristic. Artificial ants from a multi-agent system performing the functions as observed in the real ant system. Exploit stigmergistic communication. The ant colony optimization meta-heuristic relies on the cooperation of a group of artificial ants to obtain a good solution to a discrete optimization problem such as the traveling salesman problem. Artificial ants are mutants of a real ant system. The resulting shortest route mapping determined by the agents can be applied to the optimization problem. Ant colony optimization characteristics. Exploit a positive feedback mechanism. Demonstrate a distributed computational architecture. Exploit a global data structure that changes dynamically as each ant traverses the route has an element of distributed computation to it involving the population of ants, involves probabilistic transitions among states or rather between nodes. Ant colony optimization algorithms have been applied to many combinatorial optimization problems ranging from quadratic assignment to fault protein or routing vehicles, and a lot of derived methods have been adapted to dynamic problems in real variables, stochastic problems, multi-targets, and parallel implementations. It has also been used to produce near-optimal solutions to the traveling salesman problem. They have an advantage over simulated annealing and genetic algorithm approaches of similar problems when the graph may change dynamically. The ant colony algorithm can be run continuously and adapt to changes in real time. The general algorithm is relatively simple and based on a set of ants, each making one of the possible round trips along the cities. At each stage, the ant chooses to move from one city to another according to some rules. It must visit each city exactly once. A distant city has less chance of being chosen. The more instances the pheromone trail laid out on an edge between two cities, the greater the probability that edge will be chosen. Having completed its journey, the ant deposits more pheromones on all edges it traversed if the journey is short. After each iteration, trails of pheromones evaporate. The following is an example pseudocode for ant colony optimization. Now have a look at the flowchart of the ant colony optimization. Start ant colony optimization. Locate ants randomly in cities across the grid and store the current city in a taboo list. Then determine probabilistically as to which city to visit next. Move to next city and place this city in the taboo list. If all cities have not been visited, again go to the second step to determine probabilistically as to which city to visit next. If all cities have been visited, then record the length of tour and clear taboo list. Then determine the shortest tour till now and update pheromone. If the maximum iterations have not been performed, start the procedure at the first step. Else, if the maximum iterations been performed, then stop the ant colony optimization. Key parameters. Trail intensity is given by value of phi ij, which indicates the intensity of the pheromone on the trail segment ij.